So this problem has to do with trigonometry and two special laws in trigonometry which many students do not know when they're going into standardized math tests, just because of the timing of when you learn material and when the tests take place. So what we need to do is talk about a little bit of the background of the law of sines and the law of cosines. And if you haven't gotten to it yet in your math class, you will. But let's just go over those quickly right now. What the law of sines says is that if you take the sine of this angle A and divide it by the length of the side opposite that angle, okay, little a, and you can see in this picture, is the opposite side from that angle, big A. If you take that ratio of the sine of an angle divided by the length opposite the angle, that's going to be equal for every one of these pairs around the triangle. So you have this big angle C right here, and there's your little side C. So this is going to be equal sine big C over little c. And that is going to be equal to sine of big B over little b, right? That's the way the law of sines works. So in order to use the law of sines, here's what you need. You need a pair. Okay, you need a pair plus one. That's what it's called. And what that means is you need to have both A's, big A and little a, plus something else, or you need to have both B's plus something else, or you need to have both C's plus something else. And I'm going to show you why that doesn't work with this picture that we have here. If you look at the picture, what do we have in this picture? We have this is little a because it's opposite the angle big A. And this 19 over here is little c because it is opposite the big angle C. So we have little a, we have little c, we have big B. The law of sines is not going to work for us. And what you have to use instead is the law of cosines. So when you have this particular problem, you're going to be dealing with either the law of sines or the law of cosines, depending on what's given to you in the picture. Okay, so now with law of cosines, what you do to figure out the length that is missing, and in this case, they want AC. See, look at what they want. They want the length AC, that's this length right here. And in terms of these letters that I've been using, this is little b. So to use this formula, you're going to need the angle opposite the length you want, big B. You're going to need angle big B and the two sides adjacent to it. And you can see the structure of this formula. And without getting into the details of how you apply this formula, let's just look over the answers in our list. Okay, you can see that two of these answers, answer 1 and answer 3, have to do with the law of sines, because it is some kind of thing where you have a fraction where there's a sign in it. Okay, those we know we don't want because we've already established we can't use the law of sines in this triangle. We don't have enough information. We don't have a pair of an angle and a side opposite the angle. So we're going to cross out the law of sines. We don't want those ones. And you see these other two, now I'm looking at number 2 and number 4. These have to do with Pythagorean's theorem for a right triangle. Remember that old a squared plus b squared equals c squared thing? That's where you just have a simple square root answer of the style that's listed in these right here. But that's also not the case because this is not a right angle or a right triangle. So those aren't going to work for us. What's left is this giant square root, which actually looks a lot like the formula for a law of cosines, right? So that makes sense why this should be the answer that we've picked. And if you take some time and go through it trying to match up the sides with the formula, you'll see it kind of works. Now this formula was for c squared. You would need to come up with another formula for b squared, like b squared equals little a squared plus little c squared, blah, 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 minus 2ac cosine big B. But that's kind of beyond the scope of this problem. The problem is really just about identifying whether it's a law of cosines problem or a law of sines problem. The test will not expect you to memorize the law of sines and law of cosines, okay? They give those to you right here. You can see those up top. You'll always be given the law of sines and cosines as formulas, but you are expected to understand in which case one applies and in which case the other applies. So you have to keep in mind Law of sines is great if you have a pair, right? You need both A's, or you need both C's or both B's. But if you don't have a pair of sides, you need to use the law of cosines.